Take it away, Brady.
Are we ready?
Yeah.
Oh, okay. Here we are. Okay, lesson 5 group problems by Brady and Spencer. We're going to start by number 1. Same thing we've been doing all week. Determine the allele arrangement in the heterozygous parent. What you're going to do for that is you're going to find the parental offspring, which are the two most abundant. That happens to be those two right now for this problem. And then to find B, which is the allele arrangement, we're going to take the two smallest ones, which are these two right here. And we'll end up with a product that looks similar to this. We'll take the two smallest and the next two numbers up, which are 12 and 13 in this case, will be 27 divided by 206. Ignore that 205, that's incorrect. And you'll get 13.2 map units. Again, we'll do that with 1, 1, and 16 and 18 will give us 36 over 206 times 100, which will give us 17.6 map units. So we know the arrangement of the alleles, and now we just put the map units in. So M is 13.2 map units from A, and A is 17.6 map units from R. We take those map units, we divide them by 100, we times them by the total number, which is 206. That equals 4.76. Then we take the two smallest ones, which is 1 and 1, which is 2, divided by this number, which is 4.76 minus 1 to get our percentage, and that comes out to be 57.98% interference. Number 2 is the exact same way. I'm going to have a little bit different variables because I don't like using pluses and double letters and all that stuff. For the parental, we're going to find the most abundant. So we can find the most abundant right here. You might have different letters again, like I said. To find the arrangement of the alleles, we're going to find the two smallest ones, which happen to be down at the very bottom. You'll end up with a product that looks like this. You'll know that it goes with B in the middle. Your S and your V can switch spots, so that doesn't really matter. So then we go on, we take the two smallest ones and the next two smallest ones, which in this case equal 100. Divide by 1,000 times by 100, which gives us 10 map units. We do that process again, only we take the slightly higher ones, which is 10 plus 14, 150, 156, comes out to be 330 divided by 1,000 times 100, which is 33 map units. Plug our map units back in. We get V to B is 10 map units, and B to S is 33 map units. We take our map units, we divide them by 100, we multiply them by each other, we times them by 1,000, that equals 33. We take the two smallest amounts of progeny and add them together, divide them by 33 that we got from up here. Then we take that number minus 1, which will give us our percent of interference, which is 27% interference. Your turn, Hogan.
All right. Let me just get the screen share going. All right. Okay, so I'll take it from number 3. We know that the wild type is dominant, and then recessive, it gives us the variables right here. We have G, C, and S for their respective phenotypes that they portray. And so all we do for A is just like Brady's been telling us. We take our two parental phenotypes, which are the two highest numbers, we write them out, and that'll be our allele arrangement. So we have wild type C, wild type, and so on. And then for B, we just assume since there's only 6 phenotypes that we'll take 2 of them that were 0, which are the 2 missing ones. And so I have the phenotypes listed there, and that'll tell you what they are. And then the correct order for them is to have wild type, coal-colored body, and the S is in the middle, which is really just the only important thing we need to know for C. And then we take it up to C, and then we take our next two highest numbers, which are 8 and 11. We add those together with the 0, so obviously it's going to be 19. Divided by 1,000 total, multiply by 100, and we get 1.9 map units. And then we take the next two highest numbers, which are 27 and 29, add those, divide by 1,000, multiply by 100, we get 5.6 map units. So when we actually map that out, we get the C to S is 5.6 map units, and S to G is 1.9. And then for D, we take those map units individually, divide them by 100, then multiply them, we get this nice decimal, multiply that by 1,000, which is our total number, and we get 1.064. And then you get our interference. Basically, all you do is we're going to take our most double crosses, which in this case we're using 0 because there's 2 missing. So 0 divided by that's going to be 0, so 1 minus 0 is 1, so we have 100% interference for that one. And then number 4, it's just like all the rest. You get your 2 parental phenotypes, make your allele arrangement based on however you did your variables up here. And then for B, to get our gene order, the correct one we got was that we had A, N, F in the middle, which is the important part, and then BR, and those are, you can flip those. And so for C, we take our 2 double crosses, so we have 2 and 3, and then we go to our next lowest, which is 2026, and you add that up, divide by 1,000, because that's just how many we have again, multiply by 100, we get 5.1 map units. And then next step, you do the same thing, but this time we get 19 map units. So BR to F is 5.1, and F to AN is 19. And then D, we just do the same thing we've been doing, where we take our the map units, divide by 100, multiply them together, get that decimal, multiply that decimal times the total, which is 1,000 in this case again. Run our interference, so we're going to have 5, which is our lowest, and we're going to divide that by 9.69, and we'll get 0.51 and so on. So we can round it up to 0.52, and then 1 minus that's just going to be 48.48, so 48%. And then for number 5, we have our 4, we're going to have 4 possible gametes, and that comes from this genotype right here, because you can basically just, you could foil it, you could do a monohybrid cross, whatever works. And so you're going to have big A, little b, little a, big B, little a, little b, and those are all going to be a quarter chance, so 25%. And then in B, it's saying that big A is linked to big B and little a is linked to little b, and crossing over does not occur. So we just have a 50% chance for the 2 different gametes, big A, big B, little a, little b. And then C, it's saying that A is linked to B, big A is linked to big B, little a is linked to little b, but they can cross over, and so it just wants to know the genotypes for the gametes. So it's just like A, where we have the 4 different possibilities. And then in D, it's saying that, it gives us a 7.8, so we just subtract that from 100. So we have 92.2, and you divide that further, so you divide that by 2, and that's 46.1, and that'll be for both your homozygous genotypes. And then the 7.8 that we're given, you just divide that by 2 to get your 3.9, and that's for the heterozygous. But yeah, so I mean, that's how we did our work. Yay.
Yay.